Chemical reactions. We've now done a lot of background work leading to this unit. We've learned about moles, we've learned how to do calculations. Now we're going to start mixing things up. So, chemical reactions, we're going to talk about what they are, what the definition is. Balancing equations, every chemist's favorite thing to do. There are different types of reactions, of course. There'll be precipitation reactions. We're going to have more equations. Oxidation reduction reactions, very key. Different types of it, then acid and base. And then we're going to summarize everything. It's going to be a very busy unit. We will start with chemical equations. Chemical equations are concise representations of chemical reactions. So let's see what we have here. Here you have a flame coming from a gas stove. Okay, you see the blue color there? What that is we have methane, CH4, which is in gaseous form, and don't worry, we'll talk about what all these abbreviations mean as we go on, plus two oxygen models, also in gaseous form. Yield, that's what this arrow is telling us. The byproducts will be CO2, and then two water molecules, also in gaseous form. The formulas of the reactants, those are on the left side of the equation, are connected with an arrow with the formulas of the products, which will be on the right side. So reactants are what we start with, products are what we wind up with. If you want to write a word equation, write the names of the reactants to the left of the arrow separated by plus signs. So kind of like this down here. And you put the products to the right, also separated by plus signs. Let's go over some common symbols used in these equations. We'll start with the arrow sign right over here. That means yields. It separates the reactants, which are on the left side, from the products, which are on the right side. If I have an arrow, two arrows, one going each way, that means the reaction can proceed in either direction. It's reversible. S, that's a reactant or product in solid state. You place it after the formula. L would be liquid. G would be gas. And aqueous, we'll talk about that later, but that's when you have a solution and the solvent, that's a thing that something dissolves in, is water. So that's a very special case of a liquid state there. Let's see, over here we can either use the delta sign or spell out the word heat. We've added heat to make the reaction go. Or if we have something like this, that shows a catalyst is being used to make the reaction go, and we'll of course talk about catalysts later. In this case, platinum is the catalyst. And you use those in catalytic converters on your car. It helps clean the air and reduce pollution. And they have platinum in there. That's probably why they're so expensive. We're going to build this up from simple to complex. We're going to start with skeleton equations. That is a chemical equation that does not indicate the relative amounts of the reactants and products. So the way to do that is you write the formulas of the reactants to the left of the yield sign and the formulas of the products to the right. So let's talk about rusting here. We have metallic iron reacts with the oxygen in the air to produce iron 3 oxide rust. And that 3 means we have iron with a valence of +3. So we have iron, which is a metal, plus oxygen, which is a gas, yields iron 3 oxide. So those are the words. And here we put the formula down. But we're not telling you how much iron and how much oxygen. We're just sort of listing the names for it right now. And here's the word version, which we already spoke about a few slides ago. So when ignited, methane gas, that's right here, methane gas, reacts with the oxygen gas, which is in the air, and it produces carbon dioxide gas and water gas. Another name for water gas is steam. It is not balanced. We're not saying how many methane molecules we're having or how many oxygen. We're just saying these are the molecules that participate in the reaction. We will do balancing very soon.